Okay, and this chapter related with introduction computer network. And the last class, okay, there are two questions. Okay, first one is what's internet, and the second one is what's the protocol. Do you post record? Yes. Okay. After class, in the afternoon, I will post these two classes, the recordings. And okay, first, what's internet? Okay, internet is the networks, including server, okay, access network and a network core. And I think last class I gave several examples for the internet, and also we discussed internet connect things, Internet of Things. Okay, the server, okay, the device. So many IoT devices can access that internet. A second one is that okay, so if there are several devices, router, switch, okay, smartphone, smartwatch, or other laptop, okay, how to communicate, which protocol to support this transmission. So we need to know what's the protocol for the internet. Okay, based on this one, okay, we need to discuss, okay, what's the network protocols. And first, we need to consider what's our human protocols. Okay, like to ask time or ask questions or some introduction. There are some specific message or specific actions. Okay, it focus on the computer network protocols that okay focus on some device rather than the humans, and also some protocol can control or okay to help to support these communications. And what's the protocol? There give the official definition of the protocols, like to define the format, like order of message. Okay, like what's the format in the chapter 2? If we discuss the application there, we need to know, okay, what's the format for the client and for the server, and for the like the HTTP, SMTP, DNS, or other protocols, and also define some order of message. Okay, we need to control that packet. Okay, which packet? Okay, we need to, for example, to keep or deliver that packet from the lower layer to the upper layer, and which packet we need to drop that. Okay, based on if that is the corrupted packet. And also we can do some actions like I say, okay, we need to give feedback or we just deliver. Okay, there are several actions on that message transmission. Okay, and the last class. Okay, last class also I show, okay, if we compare the human protocol and the computer protocol, okay, so we can see both things, there are two stages. And first stage is to create that connection, form connection. Okay, like human protocol, you see hi, and also for the network need to like TCP connection request and response. Okay, in the TCP, in the transfer layer, we'll show there is the three-way handshaking. Okay, to create that TCP connection, and then that is just the specific. Okay, some message or some options like to get this author's web page. Then the server red part, okay, this server, okay, from the client part to the server will give feedback that okay, HTML file and other reference file. Okay, in the HTML, these protocols, okay, is special, okay, HTTP, okay, for the web. Okay, so we need to HTML just okay show the web page, and also including other files, okay, to create that web page. And here is you just know, okay, for computer network also there is the protocol. Okay, before to do the specific things, there is the connections part to connect. Okay, to create a connection between this client and the server. Okay, server part. Okay, so this is, I just review that what is internet, what's the protocol. Okay, and the second part, okay, okay, here. This is because this is first time to introduce this example, right? And in the HTTP this protocol, and in that part sections in chapter 2, there I will give it very detail about how to use get, this is we call the method, and this is URL, then we can connect request, we consider this is HTTP request message, and the server here also there is the HTTP response message, so this is client, this is server, and then the server, if we request for example, we can get the base HTML file and other reference and request this, and the server also will give that responding, for example, give that HTML file and other reference object like the image, text, audios, for that web page. And there is specific protocol, I think in the future, in the chapter 2, I will give a very detailed, why we choose TCP, why we need to use the client server architecture, what's other, what's the format, like for the client part, how to control some information, how to set some parameters. They're including the header, body, and for the server also including a lot of things. Here just a very simple example, just show if want to create that computer network protocols, there are two stage, connection, and a body part, message part. Definitely there are other functions, like put, delete, and I think here I just give like this example to show that. Next thing is let's check out. Second part, we can say we know. This internet, this is network of networks, and networks. Based on that figure, we know they are including several access network, also including like network core, like the several router switches, and in this class, we mainly focus on network edge. We discuss about several access network. Here, if you review this figure, and there are two parts. This is first part. In the inner part, this is network core, including interconnected ISP, internet service provider. And for the outer part, there are several access network. We can say there is the mobile cellular access network, there is the home access network, there is the enterprise access network, and the data center access network. And why we need separate too? For access network, like this name, so they need to provide service, internet service to the user, user device. So there is the edge router. First, any device need to connect that the edge network, and then from the edge network, then need to deliver. For example, if this laptop need to send a message to another desktop, and first they need to use the wireless signal, Wi-Fi signal, connect this access point, and forward to this switch. Forward to this switch, and then to forward to this router, and choose one path. This interface, and here this one, finally to reach the destination desk. And here we can say for the computer network, we can say first how to connect this Wi-Fi router. And if we connect this router, then there is graph. Like we can choose shortest path. With the distrct algorithm to find that destination. So there are several. Why we need in the future for the computer network, we need to discuss about the different layers. From the link layer, okay, or physical layer. We use the wireless, this is physical layer. And the link layer is there are several devices, okay? So how to connect that? Okay, connect this router, then we connect this, and based on this switch, we forward that frame to this router. And the next thing is that just choose one routing algorithm, consider forward and okay, route that packet to the destination. Okay, then give okay that packet to this desk. And then we discuss physical layer, link layer, and the network layer. And in the transfer layer to see, okay, this packet is correct or not, and the speed is good or not, and determine, okay, to control some things. Okay, then if that packet is correct, deliver to application layer. Okay, you can receive, okay, that message. So this is the big pictures for that the internet. And this class, we mainly focus on that the different access network. And in the next week, the first class, I introduced about network core. What's the packet switching to forward that packet? What's the two functions for the network core? Okay, here, let's first check out the network edge. Okay, network edge, we can see includes, okay, the host, okay, the client part, that is smartphone, and the server part, and some desktop, or like some servers in the data center. Okay, so host, client, and server, and most of servers, for example, that in the data center, and also, okay, like currently we use the cloud to save our data, also access like the Google Doc or other, okay, Google Drive, we can save all the slides or videos or other things. So that means we need to use that server, data center server, to store the data. And also next chapter, I will introduce about what some special features for the client and for the server part. Okay, so another thing, we have the device, client and server. Another thing is how to connect the device. Okay, so we need to choose the different physical medium. Okay, wired and wireless medium. Use Wi-Fi. Okay, and also we use the LTE, and also we use the Ethernet here. Different wireless and wired communication links. And the third part is for this network structure. And in the inner part, there are network core. Okay, so there is the interconnected router, okay, several routers. And also we can see based on here, we can see this is the networks. Okay, this is this region, there are another region, maybe another, okay, the regional ISP. Okay, here is this class, our first question is how to connect, okay, the host or any system to the edge router. Okay, what's the edge router? Edge router like this. Okay, the user first need to connect the first hop router, okay, this edge router, then connect this internet. Okay, anything we need to first connect first that router. So we call that is the edge router, okay, for this edge router. So how to connect that edge router, okay? And so in order to, okay, connect the internet from our smartphone, smartwatch, or the other like the iPad, okay, or other IoT device. Okay, there it needs several different access network. Okay, this access network, local access network, provides this connection. Okay, like based on this one, we will discuss about, okay, like the home access network, okay, or enterprise access network, mobile access network, or data center access network. Okay, based on this one, okay, let's see. Today we need to discuss about, okay, like the different access network. Also, we need to discuss about some physical medium, okay, and some wireless techniques. Okay, first let's check out, okay, based on here, cable-based, okay, access. For the cable-based access, we can see like this figure. Okay, this is very popular architecture here. And based on this figure, we can see on the internet, okay, there are several devices. Maybe there are also the Wi-Fi router, and there are different home here. And there is the shared, okay, the LAN or shared link. And here is the each of this, okay, this home, there is the splitter. Splitter separate this link into two parts. And the first part is that this is TV, okay, TV LAN. And the second part is there is the cable modem to connect this computer, okay, for the internet, okay. And for the cable-based access, okay, we can see for this shared LAN, okay, this one, okay, we can use like the cables, okay, like later I will show there are some coaxial cables to carry that data, okay, to send that data. And for this cable, we can see there can, for that resource or spectrum, we can separate that spectrum into different channels. Okay, this is different channel. And also you need to consider a different frequency. Okay, frequency here. And for this one, okay, this is interesting. Okay, today I check out the syllabus. This is sure this is available. I have no idea why this is locked. Maybe I will delete that, delete and upload that again. Okay. In the morning I check the syllabus. This is interesting. I will upload that syllabus again. Okay, for all the sections. Okay, for these things, okay, the first one that is to transmit used one frequency, lower frequency, to transmit that video signals, okay, for the TV. And the second part is there are, okay, some channels for some data, okay, for the internet. Okay, and the last one is there is the control channel here, to schedule, okay, that the different channels. And there is one technique how to separate, okay, that video or data for the different users, okay, different homes. Okay, there here just show we can use like the FDM, okay, FDM. So frequency division multiplexing. That idea is that for the resource, we can separate that spectrum into the different frequency, F1, F2 to the Fn. And each of these frequency, we can support user 1, user 2, finally to user n. Okay, the frequency division multiplexing, we use different frequency. And in the future, we also will learn about like the TDM. Okay, we can separate time into different time slots. Each of the time slot to support one user. Okay, just repeat that again. Okay, so this is cable-based. Okay, we'll continue to check other features for the cable-based access. Okay, we can see the data, internet data, and the TV videos transmit at different frequency. Okay, we can separate our spectrum in the lower one, TV, higher one for the internet, and shared in this cable distribution network. And another one is we can see sometimes we need to download some data, okay, watch video or download some files. Okay, download like from the internet to here to this computer. Okay, another one is that sometimes we need to upload, okay, the data to the internet. For the download, we consider this is download. Download, that means from the internet to the user. Okay, upload, that means from user to the internet. Okay, based on this thing, we needed to find, okay, this communication is asymmetric. So that means downloading rate, transmission rate, that is higher than the upstream transmission rate. Okay, so it is easy to think about that. The reason is that traditionally, most of the time, we just want to, okay, download, okay, some files, videos, or some things. And for this, okay, home access network, can see that network, including some, okay, cables, fibers attached to that home to connect this ISP, Internet Service Provider, okay, for in this case. All the data in the center part, there is the cable modem determination system, okay, that will, okay, to forward that to the ISP. Okay, this is currently the most popular architecture. And the second one, also let's check out, okay, the digital subscriber LAN. DSL, another access network. And for here, the difference, this one, there is DSL mode, okay, splitter. And this time, the internet used the existing, okay, that telephone line, okay, this telephone line. Okay, I think this is earlier version to connect that internet. So based on these things, okay, we can say there are no shared medium. Okay, we just use that telephone lines to connect. There is the DSL, the access multiplexer. This can, okay, there is switch, sometimes to switch to the telephone network, sometimes to switch to the internet, two things. Okay, so the data, internet data, and the voice, telephone voice, also just use this DLS line to the different things. For this one, for the internet, if we use the internet, and also we some voice, we go to that telephone network. And also this is the asymmetric, okay, downstream rate also is larger than upstream transmission rate. This is second part, DSL. Okay, third one, let's check out about home access network. This is more complex than the previous one. I know because we need to use previous two techniques. And the first one, okay, based on this figure, we can say it including different hosts, okay, smartphone, laptop, desktop, okay, and also there is Wi-Fi access point, and there is router, there is the box, okay, and okay, the data, okay, come into or from that the head end or the central office, and there is we can see here is the modem, okay, cable. You can choose cable or DSL. Okay, most time we use the cable based. Okay, the middle part there is the router here. There is the, okay, we can use the router like this one, and this router sometimes there is some software in that router. So the firewall, okay, network address translation. And in the network layer, I will introduce about these two techniques. And some device like this two DAC we can directly use the cable to connect that router. And someone we want to provide wireless connection. So the router also need to connect the Wi-Fi access point. Okay, there is Wi-Fi wireless access point. And this, or based on this one, we can provide wireless communication to the smartphone, to the laptop. Okay, so currently, if you purchase the one Wi-Fi router, it includes all three things together. Okay, Wi-Fi access point, routers, and the modem together to provide that service. Okay, so there are some wireless or wired device like here, smartphones or other things. Okay, so this is home access network. We can see like this. Another one is let's check out the wireless access network. Okay, here is we discuss about this. There is Wi-Fi. This also is wireless access network. Now here is I introduce two different type of wireless access network. Okay, we need to use the shared wireless medium to connect that end system to that router. Okay, and based on this one, there are two types of things. One is wireless local area network, WLAN. Okay, second part is, okay, this is the wide area cellular access network. Okay, this is, we call that mobile access network. First, okay, let's discuss about the WLAN. Okay, for the WLAN, okay, we can see like this. There is Wi-Fi router to provide wireless signal to the different host, different device. And this range, traditionally, we can say just more than 700 feet. Okay, just in the one single building. Okay, even though if there are, okay, like our department, okay, so there are several wireless routers, okay, all around just in maybe 10 meters. We can receive that wireless signals. And so there are different protocols, standards for the Wi-Fi, okay, for this one, WLAN or Wi-Fi. For the Wi-Fi, the earliest version, okay, 10 years ago, okay, that proposed that the 802.11b and A protocols, okay, and then okay evolved to the JN. Okay, this also just show the N, but current our Wi-Fi router consider like the N, okay, AC, AX, right? From the Wi-Fi, okay, we can say to Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, like this one. And so for the Wi-Fi, currently we can choose the two different frequency. Okay, somewhere most of the time we use 2.4 gigahertz, and sometimes we use the 5 gigahertz. This two different frequency. Okay, from the frequency band you can see, okay, this frequency band we can use this area. Okay, in the center frequency is 2.4, and in this area center frequency is 5 gigahertz. And there is we can say very large bandwidths. There are different channels. Each channel, okay, we can separate like, so some Wi-Fi we can separate 14 megahertz this bandwidth. Okay, this is for Wi-Fi currently. Okay, special if we involve to the like this is the Wi-Fi. Okay, here Wi-Fi 6, Wi-Fi 6 to the Wi-Fi 6E, and also in the future to Wi-Fi 7. Okay, we need to consider from also FCC to allocate more higher frequency like the more large bandwidth to give 6 gigahertz to that values for the Wi-Fi. Okay, for this case, okay, we can say for the Wi-Fi we used unlicensed band. Okay, this is free resource frequency band like this to use for the communications for the wireless. Okay, and in my graduate course, I discussed about advanced data communication. I think in the first class I introduced that different courses, and that class I'll introduce what's the physical layer, or communication system in the Wi-Fi or other techniques. Okay, and let's see. So this is for the 2.4 gigahertz, this range, this is very clouded. The reason is that one thing is at home we can use Wi-Fi to connect internet, and also there are other techniques like the Bluetooth, right? Okay, several device we can current some IoT device, or like the AirDrop or other IoT device to go home. We can choose the Bluetooth or Zigbee, that protocols in addition to that Wi-Fi. Okay, here is Wi-Fi. Okay, in this frequency 2.4 gigahertz, coexist these three wireless techniques. Okay, so we need to use which techniques? We need to use Bluetooth, Zigbee, or Wi-Fi, depends on the different applications. Okay, like Bluetooth and Zigbee mainly focus on the short range, small range, and Wi-Fi consider the long range communication. Another way is Bluetooth and Zigbee just to provide limit internet speed, and Wi-Fi provide large internet speed. So Wi-Fi, the basic purpose is to connect internet. We need to for the Zoom meeting or watch video or download some files. There are several things from the internet. And Bluetooth and Zigbee, that just connect from this device to, for example, from the smartwatch to connect the smartphones, to provide some limit transmission. And why we still use the Bluetooth and Zigbee, because Bluetooth and Zigbee, even though they have the limited speed, short range, they also have very small energy consumption. Very small energy consumption. So this is the advantage for these two things. Also Zigbee for some sensor network. And there are different things for the Wi-Fi and Bluetooth and Zigbee. This is for mainly focus I discussed the WLAN. Okay, let's see. Okay, next thing, let's discuss about wide area cellular access network. Okay, compare with the WLAN, Wi-Fi, okay, wide area cellular network, okay, with license band. License band, that means different ISP need to purchase this band, okay, or auction, okay, this band from FCC. Okay, each of this spectrum, okay, very expensive, okay, for the cellular network or mobile, okay, access network. For this one, we can see some frequency, like currently we can use the LTE or we can use the 5G to connect internet in outset. And for the like LTE or some 5G technique, for outdoor, what's the difference, okay, between that the outdoor and indoor? So indoor is not short range, okay, like even for the Wi-Fi, just carry maybe 100 meters. And for the outdoor, we want to connect internet with wireless, maybe in the to 10 kilometers. Okay, so this is very okay long range communications. So like here there is the base station, this one. Okay, and this can provide service, internet service to smartphones or other devices, even though the device, okay, that is moving. So we consider this is also need to handle mobility problem, okay, for the cellular network. And okay, so here is, okay, there are two types of things. One is Wi-Fi, another one is cellular network. Cellular network, okay, evolve from the, okay, 1G, okay, 1G, 2G, to 3G, to 4G currently, and currently we also use the 5G, okay, and different, okay, this generation communication, this generation, there are different purpose, okay, and currently, for example, if you recall that, yeah, I remember 20 years ago more, and if we consider 1G, the smartphone is very big, okay, because that just use the frequency modulation multiplexing techniques and analog signals. And for this one, just support like the phone call, this single purpose. And for the 2G here, okay, that use like the TDMA. Okay, this is sometimes FDMA. Okay, frequency division multiplexing access. Here is TDMA, time division multiplex access. Okay, I introduced these two things earlier. And to 3G, there are several techniques like CDMA or technique. And from the 3G also support some videos with the limited speed. And for 4G current, okay, we can say we can use LTE. Okay, we can use LTE to watch video smoothly, okay, and fast to download anything. And for 5G, okay, there are several techniques for 5G, okay, because from last year, okay, I think the new iPhone supported the 5G, okay. What's the 5G techniques? Okay, today I introduce that. So, okay, first, okay, let's quickly introduce about the 4G because we still use the 4G. For 4G LTE, okay, we can say check that base station, okay, as two main techniques for the physical year. And one is that use the MIMO system. Okay, current Wi-Fi also use the MIMO. This technique is same with Wi-Fi. What's the MIMO? MIMO is multiple input, multiple output. That means the transmitter is, okay, the smartphone transmitter, there are several antennas, antenna 1, antenna 2, 3. And the receiver, also there are multiple antennas. Okay, this is transmitter, this is receiver. Okay, that support that, okay, that multiple connections, okay, MIMO. So based on MIMO, so current just the single base station, if there have 10 antennas, okay, also can support different users. Second one, that use one is how to, okay, provide internet service for the different user. If there are several users, right? Okay, multiple users. For example, there are 40 or 30 users want to connect this base station. How to schedule that user to connect this. Okay, this is used one technique called OFDMA. Okay, that is orthogonal frequency division multiplexing access. Okay, this is access. Okay, based on these two techniques, okay, IoT can allocate the different resource in the time domain, in the frequency domain to the different users. Okay, current, okay, to provide service. This is the basic, okay, techniques. Okay, today also I introduced about what's the 5G techniques. So first, also that you need to involve, okay, extend some techniques from the LTE, right? From here. First one, let's check out the LTE. First technique is MIMO. Okay, so what's the some new techniques to extend MIMO? MIMO, that is multiple input, multiple output with multiple antennas at transmitter and receiver. So what's the 5G? 5G here, that shows at a base station, we need to use more antennas. Okay, from the 10 to extend to 64 or 128 antennas. Okay, so there is one first technique for the base station. It used the massive MIMO technique. Okay, so if we have the okay, if we use the MIMO, we can support more users and also can increase that internet speed. And okay, what's the second technique? The second technique is that we also can use like the, okay, so previously for the LTE, that is just used, we call that is the, okay, 6 gigahertz. That means sometimes that use the 900 megahertz communication. Someone maybe use 1 gigahertz in this range. This is also, okay, lower frequency. You can see compare Wi-Fi also that is smaller, okay, carrier frequency. So for this one, that bandwidth that is small. So that the, okay, internet speed that is limited. Okay, here also I introduced one equation to show how to calculate the speed. Okay, here I show that C is unit considered capacity or internet speed. That equal the bandwidth B, okay, times log base 2 plus what's okay, lower frequency, the minus modes of macros. Okay, the LTE, some use
Professor?
okay, just 20. Okay, go ahead.
Can you repeat like the last minute of what you just said? It like cut out the whole time.
Okay, let's see. Let's see.
It's just a section regarding the B log base 2.
Okay, can you it works? Current is good or not?
Yeah, we can hear you now.
What's the reason? Okay, from this class, I use 2 computers. One is just to see your group chat. Another one is use my iPad to plot some things. So I have no, okay. And, okay, let's continue. So the internet speed, this capacity C, that equals the bandwidth B times log base 2, 1 plus S over N. S over N, that means signal noise ratio. Okay, or someone consider, you see, signal noise interference ratios. Okay, so then based on this one, we can say in order to increase that speed, simple thing is if we can increase the B, okay, if this bandwidth from small to the larger, okay, and then we can increase, okay, internet speed. So for based on this idea, for the 5G, or in the future for the 6G, then you use the larger bandwidth, higher frequency.
Professor, we can't hear you. I think you're muted. Thank you very much.
Okay. Okay, so this is interesting. Why is the iPad automatically mute me? So I will set that, check this. Can you hear me now? Can you hear me now?
Yes, indeed.
Okay, let's start again. Okay, so I mean, for this instance, we need to use the larger bandwidth, like the millimeter wave. We can choose like 28 gigahertz. And in this higher frequency, we have the larger bandwidth. For example, we can use like the 7 in this range, 7 gigahertz. Okay, compared with previous 14 megahertz. Okay, 7 gigahertz are several times compared with like the LTE. So if we use the larger bandwidth, also we can increase the internet speed. So these two are the main techniques for the special for 5G. Another one is also there are other things for the 5G technique, like the small cell. Okay, we can say for outdoor we call that is cellular network. Okay, cellular network, that means we for one area we separate the area into the different cells. Okay, and so for 5G, okay, we consider small cell. That means one base station just cover, okay, provide service in a small range, maybe okay, like the 700 meters compared with previous, okay, 1 to 10 kilometers. If we do that, it can reduce that the N here is like reduce the interference. Okay, and based on this one, and also we can increase that the, okay, if we reduce N, also we can increase that the internet speed. Okay, and there are also the other tools. Okay, and one is like the D2D, and the last one is M2M. Okay, D2D, that means device to device. Okay, for example, we can share the some internet from this smartphone to another smartphone to forward the internet data from this smartphone to another smartphone, from this device, okay, to another device. M2M, that means machine to machine. We 5G also want to support like for the IoT device or Internet of Things device to provide internet service for the different billions of internet internet-based device, IoT device. Okay, this is the, we can say that is the 5G techniques. Okay, here, let's see. Okay, next one here is 5G. Okay, another one is let's discuss about, okay, from the 2020 to the 2030. Okay, in this range, what's the potential techniques for the next generation communication system? We call 6G. Okay, because from the last year, okay, some industry group, okay, the companies and academic researcher proposed 60 potential techniques. Maybe, okay, 3GPP will accept that, okay, proposals. Okay, someone, okay, like, okay, here, we can see 5G, we can use the massive MIMO. Okay, we can use the 128 antennas. Okay, and for the 5G, for the 6G, can we still to increase number of antennas? Okay, from 100 to the maybe 500 antennas. Okay, so this is we consider like some super, okay, super massive MIMO. Okay, that is why we can use that as the, okay, more than 100 antennas. The reason is another technique that is called, we need to move that frequency from the millimeter 28 gigahertz to the more hair frequency. We consider there is like the T-hertz communication. T-hertz like range, we can use the 0.1 T-hertz to like the 10 T-hertz communication. Hair frequency, we know for the antenna, if you check an antenna, okay, smartphone antenna or desktop antenna, if for the antenna array, this one, this antenna size, okay, this size depends on the frequency. Okay, it's higher frequency, that size becomes small. Okay, for example, if you check our LTE current lower frequency, for LTE, for example, all set LTE antennas. So this is big, okay, 7 meters. And if you check 5G, some base station access point, that is small, become very small. Okay, for the future, for the 6G, okay, that the antenna also continue decrease that. If increase the frequency, we can decrease that the size of the antenna. So we can deploy more antennas for the base station. Okay, this is two main techniques. To extend from the massive MIMO to that the, okay, the super massive MIMO, or to that the T-hertz communication. And what's the other techniques? Okay, for 6G, we need to consider, okay, we want to, okay, increase that the internet service in anywhere. So one thing is we consider like, traditionally we just like use the base station, use the Wi-Fi router. And current for the 6G, we consider like the drones communication, right? Or UAV, or some airport, or some the airplane, or some special one technique is, okay, the satellite. Okay, currently I check the news, maybe new iPhone, okay, will support the satellite communication. Why we use the satellite? Okay, the reason is that, okay, it can provide the service you can send anywhere. Okay, if, for example, if you consider earthquake in some area, the base station cannot work. So this one, we can choose the satellite to provide internet service. Okay, so satellite technique also one technique, potential technique for the 6G. And what's other things? Also for the 6G, also consider here, okay, AI. Okay, we need to make that internet more smart, more intelligent. For the, okay, cellular network core part, base station to that server, we need to do some scheduling, how to minimize that latency for different user, how to reduce that power consumption also is issues for current base stations. Also how to increase that speed of internet. We can use how to manage that resource, different channel, time, code for that the, okay, that communications. We use AI like deep learning or like federal learning, okay, to design this distributed, okay, smart AI system. So what's ours? Okay, this is we consider from frequency and hardware to see that. This is from new architecture, satellite, drones, and this is from the, okay, the smart viewpoint to see this. And the other one is current also I work on the wireless sensing, right? And last class I give an example for the microphone array-based smart speaker for the sensing, for localization, vital sign monitoring, activity recognition. Here is I also introduced 6G want to add this function, okay, into that architecture. So that want to add sensing or localization and communication together to co-design the sensing, localization, and communication. That means in the future, CSC, there one function like radar, okay, to estimate distance. Okay, so if estimate distance, also we can know our location. Also estimate speed, okay, estimate that angle arrivals, the different, okay, that the directions. And also we can use that for the other, okay. Another one is if we have that locations, also help communication to reduce latency, increase the capacity, internet speed. So 60 very interesting new feature is to add sensing localization into the communication system. Okay, this here I introduced, okay, from the 4G, I quickly review this, this slides. 4G, we just use like the Wi-Fi. We use the MIMO, okay, maybe several antennas, and use the orthogonal frequency division multiplex access protocol to support multiple users for LTE. To the also here, LTE just use like the lower frequency. To the 5G, there are two choices. One is I mentioned we can use the higher frequency. If we use the large bandwidth, we can increase internet speed. Also, this is combined, okay, compare that to the, also still use that to the lower sub 6 GHz. For example, for the long range communication, we also need to use like the 1 GHz. Because if we use higher frequency, that coverage range, this is small, maybe just up to 400 meter or 200 meter. For the long range communication, we still need to use that the lower frequency. So call this several frequency technique for 5G, we call that is 5G new radio, okay, with the different techniques. And also we need to separate large cell, okay, up to 10 kilometers to the, okay, several, okay, 500 or maybe 1 or 200 meters to create small cell, okay, for that. Okay, so like this one, we can see, okay, so previously we can see this, there is base station. And a base station can coverage maybe here, this is just single base station, okay, and provide service in up to 10 kilometers. And for small cell, we can separate this into several small cell. Each cell there is a base station. Okay, so one thing is can reduce the interference. Second thing is, okay, it provide large bandwidth. For example, we can use that in the millimeter wave for that the small cell. And another thing is D2D and M12. And if we move propose the new potentials for that 6G, because there are several demands of some new application appear, like self-driving car, AR, VR, okay, or other techniques like the 8K video streaming, or there are so many new applications require large bandwidth, high internet speed, right? For this one, we need to continue extend our wireless system to provide, okay, we can say higher internet speed using, okay, more antennas, consider, okay, large bandwidth with tethers, and consider the satellite, and use AI to control that, and use the to design that the sensing, localization, and sensing together. Okay, this is for I introduced about the here the wireless access network, including WLAN, and here is wide area cell network. Okay, next thing. Okay, let's any question in this page? Any questions? Which if any question we can okay discuss. Okay, here just this part. Here I quickly introduce about current cellular network. Earlier slides I introduced about like the Wi-Fi. Okay, to compare Wi-Fi, Bluetooth, Zigbee. Okay, no question. Let's continue to discuss another access network. Okay, so previously we discussed home access network and wireless access network. Here I introduced about like the enterprise access network. For this one, we can see enterprise access network like our college. Okay, so ECS. And for this one, okay, what's the architecture for this net access network? So first, there is our ECS institutional router, and this router connect. Okay, router always plot like this, and this is the switch like this one, and connect several switch. Okay, so for example, this switch, there are other switch, and this switch may be connect another switch, and connect different computer. Okay, maybe this one we can allocate this this interface to the one department, and this one to another department. This is another department. So just for this access network for our ECS, okay, we can create form this enterprise network from with that different switches, and there are just one the edge router or institutional router. And in the link layer, okay, we will discuss about how does the switch work, what's function for the switch, how to forward that packet, or another name, frame, from one device to another device for the switch. And in network layer, we need to discuss from this network to the internet. There are so many that the routers. Okay, there for network, two devices important. One is switch, another one is router. Okay, and here is we can see from this is this enterprise access network. Okay, mix with the different mediums, also different medium. Someone use the Ethernet. Okay, that is the wired medium. Someone also use Wi-Fi wireless medium to connect this. And like Ethernet, in the link layer will show where if we choose different catalog or different physical medium that support a different speed, up to 10 Gbps. And also we can choose Wi-Fi, different protocol current, like Wi-Fi 6 or Wi-Fi 7. We also want to reach like up to 1 Gbps, for the Wi-Fi part. Okay, this is for the enterprise network. I introduced here this figure I introduced. Okay, in order to provide this access, this function, they are including some switch routers. Connect that different with the different communication links. And now another one that is the data center access network. Data center in this part. Current data center is very, very important, but just several big company have their private own data center. Because we can say for just one single data center, and there are we can see here. This black box. In all of this, we can see there are several servers. Computers here. Each server also store the data, or some other values, or other things, software or other things, and this server all they're used like the cables to connect here. There is we call there switch. I mentioned that. Switch. This switch also consider another switch, and then there are different switch in this part. Based on these things, in the data center that include the more than thousands of the servers together and several switches to create this data center, the architectures. And like here, this is the switch, different switch, the architecture like this one. This is another level switch. And this switch also connect each other. And each of these, top of rank, this is connect this, several servers. This is one good, architectures for the data center. So if you consider, if this switch finally connect the routers, there is router. If data from the internet into this router, And then we need to consider, okay, how to forward, okay, that data and where that data, okay, go to which server, okay, go to which server part. Because if this server store more data, so maybe we need to schedule another server, okay, because there are thousands of servers. So there is the load balancer, okay, there is scheduler, okay, to do these things. And for the data center, some protocols, we can see also we need to find some routing, okay, contact control or other things, okay, for the data center network. And the feature, there are two features for data center. One is we can see large bandwidth. There are several several servers. For example, if you open your Google Doc, right? So that means, okay, that cloud computing, Google Cloud will give your file from one server. Okay, so immediately, okay, and in the application area, we will discuss that. Okay, how to create that using HTTP to request that file. And based on these things, okay, we can say the data center. If we have the data center, we can create different cloud. Okay, like Google Cloud, Microsoft Cloud, Facebook Cloud. Okay, this one can give some feedback, give your file, the web, or other things. Okay, one feature is large bandwidth. Okay, also high throughput, high internet speed. Second one is we can see we want to immediately get that file. So another feature is very small latency. Okay, in that feature. So we need to redesign the traditional computer network architecture. Not just use like TCP. Okay, for the data center, we like use the DC TCP. Okay, currently you just know this is difference. So currently, I think for the computer network, it includes several areas, okay, research area or industry area. Someone focus on like, okay, to design, to want to develop the different network apps. Someone interested in the network security, IoT security, computer security area. And someone from the computer network focus on the architecture for the data center. So a lot of problem or work focus on the data center in this area. And someone focus on the wireless I introduced before, how to develop next generation cellular network, how to update the new Wi-Fi or new IoT system for the wireless part. Okay, so another one, let's continue. This is the data center. And in the link layer, I will introduce the Facebook, the data center architecture. Here I just introduce very traditional, the one architecture for data center. Okay, currently we discussed the different access network. And the main function, there is one sending function. We need to send data from one device to another device. For the access network, we want to send data from the user device to the edge router. Okay, so for this thing, there are two devices, and this switch or this router. And then there is the communication link connect these two devices. Okay, we consider this communication link, the transmission rate is R. Okay, and how to send a message. For example, if you send one paragraph message, and so based on this one for the transmitter, okay, first step is that if larger data, we need to break that data into smaller one. Okay, so we can see here, and to break the smaller, we call this smaller chunks. Okay, if we group of the chunks, we can create this important concept, this packet. Okay, in this master, if we discuss the protocol, we use that packet. Each packet we consider L bits 1010. Okay, so this is the packet. Okay, this packet to store the L bits. Okay, 10111110 L bits. Okay, and for this one, okay, if we have more data, so we need to. This is the first packet. Also, there are second packet here. Okay, then we one packet to deliver, okay, from one node to another node. Okay, so over this transmission rate R, so what's the the delay between to transmit, okay, that the packet from one node to another node. Okay, based on this one, we can say the packet transmission delay that equals packet length, L. Okay, L, that means this, okay, this packet was how many bits in this packet, L bits. Okay, over the transmission rate. So finally, we can get that, okay, seconds or several seconds for the transmission delay. So, and in the next week class, I also introduce several other delays, like the here is transmission delay. Also, I introduce about like the propagation delay, or like the queuing delay, or like processing delay, the different delays. Here is you just know transmission delay depends on packet length, okay, and link transmission rate, okay, for this one. Okay, next one, also we have time, I introduce about, okay, physical medium for the link layer. First thing, what is physical medium? So, because if we want to transmit packet, okay, packet including L bits, and then that packet propagate between that two, device pairs, right? So what's the physical link to support this transmission, to support that packet? Okay, there are two mediums. I think we discussed that before. One is the getting medium, another one is ungetting medium. Getting medium, that means for the, okay, that signal propagate with that is a solid medium, like the copper fiber coax. And ungetting medium, like we use the Wi-Fi RT, this radio, okay, that medium. Okay, first, let me introduce about the getting medium. Okay, getting medium here, like a traced pair. Okay, the first earlier version. So for traced pair, you can check this. Okay, this. Okay, so this always use like two in solid copper wires. Okay, to create that the transmission links, and there are different this type of these pairs. Okay, we can see from earlier versions for trace pair just for the telephone network. Okay, and to currently also we can use the traced pair TP for the Ethernet, like the catalog 5, based on that okay material for that each of these files. And catalog 6 also support 10 gig BPS that Ethernet speed. This is first one. Also, this is cheap for the easy to install these links. So we use that okay the traced pair. And the second party also currently we use the coaxial cable. Okay, special coaxial cable currently use the TV and the internet. Okay, and based on this one, this is we can see here there are more. We can see use two concentric that Kuiper conductors, more isolation for the different links. Okay, the good medians, and also can address some crosstalk or interference. Okay, from other signals, or provide bidirectional communications. And on this cable also can support multiple frequencies. Each channel, okay, we can see previously we discussed about cable access network. So I introduced about this line, right? It is support, we use like here for that medium, there are different frequency here, right? We can see some ones for the videos, some videos, someone for the data for different channel. Each channel and can support okay like is more than 100 Mbps. So this one that is the better than the traced pair, more expensive. Okay, for this one. And the last one, this is best one for the communication. We can see this is the fiber optical cable. Okay, like this. Okay, we can see this use glass fiber. Okay, this is more okay good material to isolate some interference, some noise, crosstalk, or other things. So it can get very lower error rate. Okay, for this one, and a very robust to some wireless noise in this one, and also repeaters also space far apart from this one. Based on that features, fiber optical cable features, it can provide high speed communication. Okay, and we can say up to 100 okay gig BPS. Okay, for the fiber optical. So finally, if we compare with the traced pair, coaxial cable and fiber optical cables, we can see this one can provide highest, okay, the internet speed. Now this is the second one, this is third one. Okay, but another thing is this is more expensive. Okay, next one, last one, we introduced 3 GATA medium. And here is I introduced for the wireless radio medium. Okay. And for the wireless radio medium, okay, we know, okay, for the like Wi-Fi, LTE, that signal use like we can say signal carrying a different band. Okay, lower band, sub-6 gigahertz, or higher band like the millimeter wave, or some Wi-Fi 2.4 gigahertz or 5 gigahertz. Okay, and if we compare with the GATA medium and un-GATA medium, the main feature is that GATA medium for the transmitter and receiver, if we use copper cables, and so there are just direct paths. There are no any refractions or other things. Okay, just one path to transmit. If we transmit data X and receive Y directly equal X, there are no interference. So what's the wireless medium? If there we use like the Wi-Fi to transmit packet, this transmitter, this is receiver. So wireless signal, if we just consider indoor environment, and this one is okay. Sometimes one is there is the loud set just from the transmitter to receiver, and also there are other signals refractions here if their box reflect this. So there are multiple channels here, okay, to the receiver, not just original X. Okay, this is X, maybe this is X, okay, 1, X2, X3. So receive signal current become more components. If we send X, okay, and receive Y, current equal X, need to multiply 1 parameters. We call this is H. Okay, what's H? H is channel. Okay, so compare with wireless medium. So for the wireless medium, channel is important features. Okay, so based on this one. So if we want to recover or demodulate X, we want to, at receiver part, we transmit hello. And receiver want to get this hello, need to remove the H. So how to remove the H? So this is use one interesting packet, the payload. We need to use the common known payload X, for example, X0. Okay, this X0 that is known for the transmitter. Okay, transmitter, receiver, both sides know this value. For example, like this is 110. And if the transmitter sends this packet, including this header, receiver first check out header, okay, to know this transmit X is bits, and receive get here is Y0, okay, and over the channel X0. So based on this one, okay, X0 and Y0, receiver know these two variables, and based on this one, it can estimate H, Y0 over X0, and then if we estimate this H, if we consider H in the short term, if that is constant value, then for the real data part, okay, the other X, we just use Y over H to estimate, okay, the other data. Okay, this is header, this is data, so we can estimate H. So the communication channel is balancing for the communications. The channel is balancing, and next week, I will introduce this channel is very good feature for wireless sensing, for localization or other for the vital sign monitoring based on this reflection. Okay, let's finish here. Okay, I think in the afternoon, okay, I will post all the recordings on the canvas. And if you want to add this class, also you can email me. Okay, let's finish here. Thank you, everyone. See you, next week. This week, there are no homework.